Hello, everybody. Today on this episode of the podcast, today we're going to be talking about flare stars, otherwise known as UV Ceti stars, since UV Ceti, the first flare star ever discovered. Well, it's pretty self-explanatory. So we're going to take a look into some of flare stars. So let's start off. Oh, sorry, that was my computer. All right, let's start off with the one that started it all, UV Ceti, otherwise known as Gliese 5665b or Luton 726-8b or BL Ceti. Yeah, I know, a lot of designations. These first two names, Gliese 65 and Luton 726-8 8 it is a binary star system. So UV Ceti is actually within a binary star system. Not both stars flare. It consists of a red dwarf, aka A, like Gliese 65A or Luton 726-8A. My God, so many designations. Yeah. And from the designation, you can tell that it's in the constellation Cetus, deriving from the term Ceti. And this star system was discovered in 1948, so that's around like almost a century ago. Well, more like 80 years ago. So, how many millennia is that? I'm not sure. I'm trying to use that term, but anyways, back to that. So let's see. So, onto the concept of UV Ceti's flares and how it became something. Well, according to Wikipedia, which I'm reading this off of, well, you probably won't find it because I'm just basically paraphrasing it, and I'm not even reading at the page that I'm saying, so keep that in mind. Flares are bursts of energy from stars. Now, as you know, the sun may release solar flares, but that doesn't mean it's a flare star. Flare stars are stars that release flares frequently. Well, yeah. Most flare stars will frequently release those, like I just said. I have no idea why I repeated my sentence. But anyway, alright, yeah, that's CBC time. Yeah, it's very special though. They're only called flares on other stars because we refer to solar as the sun. So, it's because solar is the sun. Duh. That's what it means. Solar equals sun. The stars called like on Earth. Alright. Yeah. Alright, so next. Alright, so I forgot what it was. Oh yeah. So next up on our list is UV Ceti. Now, it is a very powerful flare star, and it has several designations such as EV LAC, Gliese 873, or HPI 112460. Now, it is a faint red dwarf star that is around like 15 light years away in the constellation Lacerta. Again, from the designation. It is, well, let's see. Yeah. Alright. I'm just skipping some certain stuff. Let's see. M3.5, whatever. Yeah, so yes, it is also a flare star, but it's also a powerful flare star. Because considering at one point in its life, it is also much younger than the sun. So, but anyways, also scientists have discovered that one time in this star's life, a flare explosion was so powerful that the star turned blue for a few seconds. Now, if you don't believe me, you can Google that. So, if you don't believe me, I mean, the internet isn't always true, as we know. But I'm hoping that's true, though. Even if it isn't. Yeah, so that's another flare star. Yeah. Yes, yeah. I don't know what I just said there. But yeah, flare stars are, well, yeah, they are cosmic, well, well, they're like zombie stars, but they don't die. They don't explode and die or anything. They just release bursts of energy that have been hiding under their core. Okay, well, kind of the wrong way to put it, but yeah. All right. I'm just looking up lists of flare stars because there's literally the only two flare stars that I know of. List of flare stars. This isn't. Oh yeah. So. Oh yeah, I forgot about this. So. Now. So yeah, as we know, flare stars are variable stars. Yeah, you probably know that. Well, not since you clicked the video or anything, but yeah. Pretty much, yeah. So, flare stars or UV stars, including UVN types of stars, which are more than 1,620 stars within that classification, are very, very powerful. I have no idea why I said that. Okay, so as we know, so next on Proxima Centauri. Now, Proxima Centauri is is a red dwarf star and the closest star to us in the Alpha Centauri system. Now, it does not orbit the binary system Alpha Centauri A and B, or Rigel Centaurus, or Tulamon, but does have its own little planetary system consisting of Proxima Centauri D, B, and C. Don't ask me why it's in that order. I have no idea. But um, and like most flare stars, it randomly undergoes dramatic increases in brightness due to magnetic activity. And this also has a lot to do with ultraviolet light and stuff. Yeah, yeah. Also, another red dwarf, Wolf 359, is also another flare star. It is near the ecliptic plane of which all the planets in the solar system orbit. I'll get back to you on that. I'll get back to all of you on that in another episode of the podcast, possibly. Hey, look, Wolf 359 is a podcast. Podcast in a pod. Nothing. All right, well, so yeah, it's a red dwarf in the Leo constellation, and it is outside. It's outside of the main constellation, but as it says here on Wikipedia, it's outside of the main constellation, but is still contained within the border, which borders the Virgo, Ursa Major, Leo Minor constellations. So yes, all right, all right. Well, we have that. And let's look at some other stuff here. Wow, its flares emit strong bursts of X-ray and gamma radiation. Wow, kind of like APEP. I'll get to you and also talk about that later. All right. So, well, yeah, there are other red dwarfs closer to the sun. What happened to me? All right. Anyway, so like Wolf 359, there are many red dwarfs that are close to Earth, which most of them are. And most of those are flare stars like Wolf 359, Proxima Centauri. And now Barnard Star. Now Barnard Star and the brown dwarfs Lumen 16 are not. I'm assuming they're not flare stars. I really don't know. That's not what I'm getting at here. Lumen 16 is just a binary brown dwarf system, so no. If you want to hear more about brown dwarfs, you can see them in my future book, which will probably come out by the time this video gets more than views in the double digits. So, yeah. All right, now let's look at some. Now let's look at some more. Now let's look at some more flare flare stars. All right, so next on our list is FL Virginis. As you can tell, this is in the Virgo constellation. Virgo, the Virgin. Gosh, what a name. What a name. Anyway, anyways. Alright, so this is also known as Wolf 424. So we have another wolf. So we have another wolf. And it is a binary star system. And is right next door to the constellation Leo. In the Virgo constellation. And I'm just looking here at the actual constellation, and is technically inside the constellation, technically. And like most red dwarfs, they are not visible to the eye, to the unaided eye. And these are two red dwarfs orbiting around each other, so make them binary. And they are both flare stars, so that's interesting. Alright. Yeah. Yeah, they may experience sunspot activity, it says here. There's not really much else here. It's basically a double red dwarf system that both flare due to high luminosity changes in their atmospheres. So that's pretty much what it is. Otherwise known as Omicron Virginis. That is yeah. Alright, so let's look. Alright. So far I'm not finding any sources of. Oh, no. No, clicked on the wrong tab. Not that anyone cares anyway. Alright, let's look here. Yeah, also, if you undergo the math of how long you've been listening to this video, you will realize that all the red dwarfs mentioned, such as Omicron Virginis, Proxima Centauri, Wolf 359, those are red dwarfs. Yeah, those are red dwarfs. They are red dwarfs, so yeah. Alright. This website for more of the star. For more types. Alright, this is just all about UV Ceti, so I'm gonna stop there. This has actually been the longest episode of the podcast so far. So I'm gonna stop it right here. So thank you for listening, and I will see you in the next episode. Bye.